versus F-22 versus F-16, the ultimate comparison. 3 aircraft, 3 different philosophies, one question that has fascinated engineers, pilots, and aviation enthusiasts for nearly 2 decades. Which one is actually the best? But here's the catch. The answer is not as simple as you might think, because each of these machines was designed for a completely different job. And when you look under the skin, past the speed, the shapes, the numbers, you begin to realize that comparing them is like comparing a chess grandmaster, a sprinter, and a Swiss Army knife. In this video, we're going to break down the F-35 Lightning II, the F-22 Raptor, and the legendary F-16 Fighting Falcon. Not to declare a single winner, but to understand what makes each one unique. We'll talk about stealth, speed, technology, and the real-world roles they play in modern aviation. So strap in, because this is the ultimate comparison. 3 different worlds. Let's start with a quick introduction to each aircraft. First, the F-35 Lightning II. This is the newest member of the family. Sometimes called the Joint Strike Fighter, the F-35 was designed from the ground up to be a multi-role platform. That means it can perform many different types of missions, from gathering intelligence to supporting ground operations, all while being extremely difficult to detect. The F-35 is often described not as a traditional fighter, but as a flying supercomputer. Its most powerful feature isn't an engine or a gun, it's data. We'll get to that later. Next, the F-22 Raptor. If the F-35 is a Swiss Army knife, the F-22 is a scalpel. It was built for one primary purpose: air dominance. The Raptor is faster, more agile, and carries more fuel and systems dedicated to outperforming any other aircraft in the sky. The F-22 entered service in the early 2000s, and to this day, it is considered by many experts to be the most capable air-to-air platform ever built. But it's also expensive. So expensive that production stopped after less than 200 units. And finally, the F-16 Fighting Falcon, also known as the Viper by pilots who fly it. The F-16 is the old veteran. It first flew in the 1970s, over 50 years ago. But don't let its age fool you. The F-16 is still in active service with dozens of countries around the world. More than 4,000 have been built. It's lightweight, incredibly maneuverable, and relatively affordable. The F-16 proved that you don't need a huge, expensive machine to be effective. Sometimes simplicity and reliability win the day. So, 3 aircraft, 3 different eras, 3 different design philosophies. Now let's start comparing them where it really matters: stealth and design. Stealth and design, the art of not being seen. Stealth. It's the word you hear most often when people talk about modern military aviation, but what does it actually mean? In simple terms, stealth is the ability to reduce an aircraft's visibility to radar, infrared, and other detection systems. It's not about becoming invisible to the human eye. That's easy. It's about becoming invisible to the electronic eyes that scan the sky from hundreds of kilometers away. Think of it like this. When a radar station sends out a signal, that signal travels through the air until it hits something: a bird, a cloud, or an aircraft. Then a small part of that signal bounces back to the radar receiver. The stronger the return signal, the larger the object appears on the screen. A conventional aircraft, like an old airliner, reflects a huge amount of radar energy. It looks like a barn on the radar screen. A typical fighter from the 1980s looks more like a car. But a stealth aircraft, it can look as small as a golf ball, or even smaller. So, how do the F-35, F-22, and F-16 compare in this area? Let's start with the F-16, because it's not a stealth aircraft at all. The F-16 was designed in an era when stealth was not a priority. Engineers focused on aerodynamics, thrust-to-weight ratio, and cost-effectiveness. The F-16 has a traditional round air intake, vertical tail fins, and external stores, all of which reflect radar energy very well. That doesn't mean the F-16 is bad. It simply means that in a modern detection environment, the F-16 would be visible from a long distance. Its survival depends on speed, maneuverability, and electronic countermeasures, not on hiding. Now, the F-22 Raptor is a completely different story. The F-22 was the world's first operational stealth fighter designed for air dominance. Its shape was carefully engineered using something called planform alignment. All the leading edges of the wings, tails, and control surfaces are set at very specific angles so that radar waves bounce away from the source rather than back to it. The F-22 also uses radar-absorbent materials, or RAM, baked into its skin. These materials convert radar energy into tiny amounts of heat, which then dissipate. The result is an aircraft with an incredibly small radar cross-section, often compared to that of a marble. But the F-22 is not the stealth champion in this comparison. That title goes to the F-35. Why? Because the F-35 benefits from 20 more years of research and computer modeling. The F-35 takes the same planform alignment principles and refines them even further. Its surface is smoother, its edges are sharper, and its skin uses a new generation of durable fiber matte RAM that requires far less maintenance than older stealth coatings. But there's another layer: internal carriage. The F-35 was designed to carry all of its mission equipment, fuel, sensors, and internal stores inside the fuselage. There are no external fuel tanks or pods hanging off the wings when stealth is required. This keeps the aircraft's shape perfectly clean, with no protruding surfaces to reflect radar. The F-22 also carries its stores internally, but its external profile is slightly less refined than the F-35's. And the F-16? It carries everything externally, which is why it lights up on radar like a Christmas tree. So, in terms of stealth, the F-35 wins, followed closely by the F-22. The F-16 does not compete in this category because it was never designed to. But stealth is only one part of the story. Let's talk about speed and performance. Speed and performance. The need for speed. When most people think of fighter jets, they think of raw speed, afterburners, breaking the sound barrier, pulling high G turns. And in this category, the three aircraft are surprisingly different. Let's start with the numbers. The F-22 Raptor is the fastest of the three. It can reach speeds of over Mach 2.2. That's more than 2,300 kilometers per hour. And here's the incredible part. The F-22 can maintain supersonic speeds without using its afterburner, thanks to something called supercruise. Very few aircraft in the world can do that. The F-22's engines, two Pratt & Whitney F-119s, produce an enormous amount of thrust. Combined with its lightweight airframe and aerodynamic design, the Raptor can climb like a rocket and turn tighter than almost anything in the sky. Now, what about the F-35? The F-35 is powered by a single engine, the Pratt & Whitney F-135, which is actually the most powerful fighter engine ever built. It produces more thrust than the F-22's individual engines. But the F-35 is also heavier and has a different shape, optimized for stealth rather than pure speed. As a result, the F-35 has a top speed of around Mach 1.6, about 1,600 kilometers per hour. That's slower than the F-22, and even slightly slower than some versions of the F-16. But here's the thing. Speed is not the F-35's primary advantage. The F-35 is designed to be a first-look, first-shot platform, not a drag racer. It doesn't need to be the fastest because it can see and track other aircraft long before they see it. And finally, the F-16. The F-16 is surprisingly fast for its size and age. Depending on the model, it can reach Mach 2.0 or slightly higher. But the real magic of the F-16 is not top speed, it's maneuverability. The F-16 was the first production fighter to use a fly-by-wire system. Instead of mechanical linkages between the stick and the control surfaces, the pilot's inputs go to a computer, which then moves the surfaces. This allowed engineers to design an inherently unstable aircraft that could turn incredibly fast. Pilots often say the F-16 feels like it's part of your body. It responds instantly. It can pull up to 9 Gs, meaning 9 times the force of gravity. That's physically demanding for the pilot, but it makes the F-16 one of the most agile fighters ever built. So, in terms of raw performance, F-22 is the fastest and most agile overall. F-16 is incredibly agile, especially for its age and cost. F-35 is slower but still highly capable, and its performance is more than adequate for its mission profile. But speed and agility are becoming less important in modern aviation. What really matters now is technology. Technology and innovation, the flying information platform. If the F-16 represents the past and the F-22 represents a bridge between past and future, the F-35 represents a complete rethinking of what an aircraft should be. Let me explain. The F-16 was designed in the 1970s. Its cockpit is filled with analog gauges, mechanical switches, and a small radar screen. Over the years, the F-16 has been upgraded with digital displays and modern sensors, but at its core, it's still a pilot-oriented machine. The pilot flies the plane and the systems help. The F-22 took a big step forward. Its cockpit is all glass, large color displays, advanced radar, and a sophisticated electronic warfare system. The F-22 was the first fighter to integrate sensors so that the pilot sees a fused picture of the environment. But the F-22's technology, while groundbreaking in the 1990s, is now nearly 30 years old. Then comes the F-35, and this is where things get really interesting. The F-35 is often described as a flying information platform, not just a fighter jet. Its most important capability is not speed, not stealth, not even its engine. It's data. The F-35 is equipped with a sensor suite called the AN/APG-81 radar, the Distributed Aperture System (DAS), and the Electro-Optical Targeting System (EOTS). These sensors collect enormous amounts of information from the environment: radar signals, infrared heat, visual imagery, and electronic emissions. But here's the magic. The F-35's computers automatically fuse all that data into a single intuitive picture. The pilot doesn't have to look at 5 different screens and mentally combine the information. The aircraft does it for them. And that picture is presented through the pilot's helmet, a $400,000 piece of engineering that projects flight data, targeting information, and video directly onto the visor. The helmet is connected to 6 infrared cameras mounted around the aircraft. Together, they create a 360-degree view of the world. The pilot can literally look down through the floor of the cockpit and see the ground below. They can look behind them without turning the aircraft. It's like having X-ray vision. But the F-35's real power goes beyond the individual aircraft. The F-35 was designed to share data with other platforms, other F-35s, older aircraft, ships, and ground stations. This creates a shared picture of the operational environment. What one F-35 sees, the entire team sees. That is revolutionary. It means that an F-35 can fly into a complex environment, silently map every signal source, and then share that information with an F-16 flying safely at a distance. The F-16 suddenly has the same awareness as the F-35, without having the same stealth or sensors. So, in terms of technology, the F-35 is in a league of its own. The F-22 is still very capable but aging. The F-16 has been upgraded many times, but it cannot match the sensor fusion and data sharing capabilities of the 5th-generation aircraft. Now let's look at how these aircraft are actually used in the real world. Real-world application. Different tools for different jobs. You might be wondering, if the F-35 is so advanced, why do countries still fly F-16s? And why did the US stop making F-22s? The answer comes down to 3 things: cost, mission requirements, and numbers. Let's start with the F-22 Raptor. The F-22 is an extraordinary machine, but it is also extraordinarily expensive. Each F-22 cost around $150 million, and that's just the aircraft, not including development, maintenance, or training. Because of its high cost and the fact that the Cold War had ended, the US government decided to stop F-22 production after 195 aircraft. Today, the F-22 fleet is relatively small, and it is used primarily for specific high-end defense scenarios where its unique combination of speed, stealth, and sensors is needed. The F-22 does not carry as many external systems for ground operations. It was designed to dominate the air environment, and that is what it does best. But it is not as flexible as the F-35. Now, the F-35 was designed to be the opposite, flexible and affordable enough to be built in large numbers. There are three main versions of the F-35. The F-35A for conventional runways, the F-35B with short takeoff and vertical landing capability, perfect for small ships or damaged runways, and the F-35C for aircraft carriers. More than 900 F-35s have been built so far, and the total planned production is over 3,000. That makes the F-35 a common platform for many countries, including the United States, the United Kingdom, Australia, Japan, and others. The F-35 is used for a wide variety of missions, gathering intelligence, supporting ground forces, patrolling airspace, and operating in complex electronic environments. Its ability to share data makes it a force multiplier. It makes everyone around it more effective. And then, there's the F-16 Fighting Falcon. The F-16 is the workhorse. It is relatively cheap, about $20 to $30 million for a modernized version. It is easy to maintain, it can operate from rough runways, and it has been continuously upgraded for over 50 years. More than 25 countries still fly the F-16. Some have upgraded their F-16s with new radars, new cockpits, and even some stealth features like conformal fuel tanks. The F-16 cannot match the stealth or sensors of the F-35, but it doesn't have to. In many defense scenarios, the F-16 is good enough, and when you need to patrol large areas, train new pilots, or operate on a budget, the F-16 is the smart choice. So, in real-world application, F-22 is a specialized low-volume platform for high-end air dominance. F-35 is a high-volume multi-role platform for the future. F-16 is the reliable, cost-effective workhorse that will likely fly for another 20 years. But now, the question you've been waiting for. Final verdict. Which aircraft is the best? Which one is the best? The honest answer is, it depends entirely on what you need. If you ask a pilot who values raw performance and agility above all else, they might say the F-22 Raptor is the best. Nothing else can climb faster, turn tighter, or accelerate like the Raptor. It is the king of the air environment, a masterpiece of aerodynamics and engine design. But the F-22 is also rare, expensive, and less flexible than its younger sibling. If you ask a mission planner who needs to cover many different types of operations, from intelligence gathering to supporting ground teams, they will almost certainly choose the F-35 Lightning II. The F-35 is not the fastest and it's not the most agile, but it sees everything, it knows everything, and it shares everything. The F-35 represents a fundamental shift in aviation. It's not about how fast you can fly. It's about how much information you can collect, process, and distribute. In that sense, the F-35 is not just a fighter, it's a node in a network, and networks are the future. And if you ask a defense minister who has to balance a budget, train dozens of pilots, and protect a large airspace, they might say the F-16 Fighting Falcon is the best, because you can buy 10 F-16s for the price of one F-22. You can upgrade them over time, you can operate them from almost anywhere, and they have a proven track record spanning half a century. The F-16 is the ultimate example of good enough being truly great. So here is the final verdict. For pure performance and air dominance, F-22 Raptor. For advanced technology, data integration, and future readiness, F-35 Lightning II. For cost-effectiveness, versatility, and proven reliability, F-16 Fighting Falcon. But if we had to choose one aircraft that represents the direction aviation is heading, it has to be the F-35. Because the era of the lone fighter dogfighting in the sky is fading. The future belongs to connected systems, sensor fusion, and shared awareness. And no aircraft does that better than the F-35. The bigger picture. So, after all of this, what have we learned? We learned that comparing aircraft is not about declaring a winner. It's about understanding design choices, trade-offs, and mission requirements. The F-22 was built to be the ultimate performer, and it succeeded. The F-16 was built to be affordable and effective, and it exceeded all expectations. The F-35 was built to be the most advanced information platform in the sky, and it is redefining what an aircraft can do. Each of these machines represents a moment in aviation history, and together they show us how far engineering has come and where it might go next. What will the next generation look like? Will we see unmanned systems taking over? Will artificial intelligence fly alongside human pilots? Will aircraft become even more invisible, even more connected? Those are questions for another video. For now, we hope you enjoyed this ultimate comparison. If you did, please consider subscribing and hitting the notification bell, because we are constantly exploring the world's most amazing technology. And let us know in the comments, which aircraft is your favorite and why? We read every single comment. Thanks for watching, and remember, the sky is not the limit, it's just the beginning.